alkyl in order to form alkyl iodides. The recording has started right now. So let me just, those who are watching the
Sir, what is
recording,
that HBr?
wait a second. Yeah. Those who are watching the recording, we have started from here. Just note down this. Okay. Now, HBr is when you react NaBr and H2SO4, you will form HBr. Got it? And we have seen
Okay, sir,
HBr.
it's a compound or haloalkane plus Br like that.
Wait a second. Is this your first class for haloalkane, Pia?
Sorry, sir?
Is this your first class for haloalkane?
No, sir.
So you have, what is in the first class we saw, na? Haloalkane. What is an haloalkane? Tell me. Read it.
Haloalkane is a chain of hydrocarbons.
Chain of hydrocarbons only. Can you read it from the notes actually, Fia? What is a haloalkane? See, read here. First line. Did you read it, Fia?
Yes, sir.
So what is a haloalkane? Tell me.
It is alkyl or aryl group attached to a carbon, attached to a hydrogen.
Hydrogen.
Compound.
Hydrogen.
Yeah, hydrogen compound.
Compound. No, Fia, if you can't read,
Halogen.
Halogen. What is a halogen?
Halogen is Br over here.
Yeah. So is it what it is attached with? Br is attached with what? Tell me. Is this an alkyl group or an aryl group? Hydrogen. Yes, Fia.
Yes, sir.
Is this an alkyl? Do you understand what is an alkyl group?
Yes, sir. That R is an alkyl group.
R is an. So is this an alkyl group? H
Yes, sir.
is an alkyl group.
Yeah.
What is an alkyl group? R mat boliyega. What is an alkyl group?
It is like CH3 like that. In a hydrocarbon chain, aliphatic chain, it will be alkyl group.
Fine. So is this alkyl group? What is the necessary condition for something to be alkyl? It should be a hydrocarbon, right, Fia?
Yes, sir.
What is the meaning of hydrocarbon? What should be present?
Hydrogen and carbon.
Is carbon present here?
No, sir.
Is it a haloalkane?
No, sir.
Got it? समझ में आ गया ना Pia?
Okay, sir. But then what is that?
Hydrogen bromide.
Okay.
What is HCl?
Okay,
Hydrogen
sir.
chloride. Okay. Write a note here. Potassium iodide or sodium iodide is not used with H2SO4. For the preparation of alkyl iodides. Because H2SO4 is a strong oxidizing agent which oxidizes Hi to I2, and therefore reaction of alcohol with Hi cannot occur. Now, when we are trying to make alkyl iodide using this particular reagents. So I will use alcohol plus I will take sodium iodide or potassium iodide and H2SO4. Now, some of the potassium iodide and H2SO4, they will react with each other and they will form hydrogen iodide, Hi. Now, obviously, not all H2SO4 will be reacted, right? When we have formed first Hi, first Hi molecule is formed. So at that time, there will be some H2SO4 still remaining in the solution. So what happens? Hi, this Hi, it reacts again with H2SO4 and it forms I2, iodine, plus H2O and sulfur dioxide, sorry, SO2. Now, since there is no Hi, alcohol cannot react with Hi. What happened? Alcohol, or rather this Hi which is formed here, it should have reacted with alcohol. But since it got a strong oxidizing agent such as H2SO4, it reacted first with H2SO4. It reacted first with H2SO4 and formed iodine. Obviously, iodine is not reactive. Iodine is not reactive and it cannot react with alcohol. So that is why there is no Hi formed here. Okay. So this reaction not occurs. Rather, this reaction occurs. And then here you have alcohol, which is unreactive. Now, in order to avoid this, now since H2SO4 is causing problem because it is what? Because it is a strong oxidizing agent. So what we use? We use a mild oxidizing agent. Is right here. To avoid this, mild oxidizing agent such as H3PO4 is used. Which provides Hi. For reaction and forms alkyl iodide with alcohol. All of you wrote this down, yes or no, please tell me. Is there anyone who is still writing? After this, you will write a remark. No.
Sir, can you go up? Can you scroll up? Yes.
Yeah, let me know once you're done.
Yes, sir, done.
In remark, you'll write. See, we have seen many methods in which we can use reagent with alcohol to form haloalkane, right? All of these reactions, what we have seen, please write the above methods cannot be used. The above method cannot be used with phenols to form haloarine. To form haloarine because phenol shows resonance and COH bond in phenol has partial double bond character. Which is difficult to break. So what happens in all of these reactions? ROH, and we use some reagent here, and we got RX. That means R that is bonded with halogen. So what happened? This ROH, that means carbon OH bond is being broken. If we are going to use the same reagents, and if we want this phenol, same reagents, and I want a haloarine, then we have to break this bond. But since this bond is having partial double bond character because oxygen has lone pair, and since it is having lone pair, it is going to move the electrons here like this, showing resonance like this. That is why this reaction cannot take place, because it has partial double bond character. Please write this down. Let me know once you're done. Partial double bond character, that means it will be a strong bond, and strong bond cannot be broken easily. This question can come directly, like why phenol cannot be used for the preparation of haloarine. So you'll write this part, because phenol shows resonance and COH bond in phenol has the partial double bond character, which is difficult to break. That's it. Is there anyone who is still writing? Anyone who is still writing? No one. Write the B part. So first of all, we saw method of preparation using alcohols, right? Write the B part using hydrocarbons. Okay. In hydrocarbons, we'll look at the first method, free radical halogenation of alkenes. Free radical halogenation of alkenes. Okay. So an important thing here, whenever this word halogenation is being used, understand that we are going to do reaction with X2. Okay, halogen. Fluorine, that means we are doing fluorination, that means we are using F2. Bromination, Br2. Chlorination, Cl2. Okay. Alkenes means we are going to use simple alkenes without any double bond or triple bond, without any double bond or triple bond. So alkenes are generally shown as RH. Alkyl group, for example, methyl group आपका होता ना, methyl is CH3 and methane is CH4. So you add one hydrogen to a alkyl group, you will get alkene. So alkenes are generally shown as RH. Alkyl group with one hydrogen will give you alkene. Now we are doing halogenation, that means we are going to react with X2. Free radical meaning you are going to use one of these reagents. What are those reagents? Reagent is helper. Okay, reagent is helper. I will tell you what is helper is. Now what happens? One of the hydrogen will be replaced by halogen atom. One of the hydrogen will be replaced by halogen atom, plus you will get HX. If you want to see what is happening, remember the reaction like this. Okay, we are getting RX plus HX. Please write this down, then we'll see what is helper. So here both of these things are important. Okay, halogenation and helper. Any one of the helper. Helper देखेंगे क्या है? So please see here. What is helper? Helper is made up of H, E, L, and TER. So H is heat, which can be shown like this. E is electricity. L is light. They can also say sunlight, or they can also write H nu. If you remember the second chapter of 11th standard atomic structure, in that we showed the H nu is what? It is the energy of a photon, right? So instead of light, they can write sunlight, or they can write H nu. And what is PR? PR is peroxide. If we are using any one of these, then we are doing what? Halogen plus light, free radical halogenation. Halogen plus peroxide, free radical halogenation. Halogen plus heat, free radical halogenation. In this, light is very important. So all of these are known as radical generators. क्या बोलते हैं इन सब चीजों को? हेल्पर को क्या बोलते हैं? Radical generator. Radical generators. Is everyone done? Yes or no? Please tell me. Anyone still writing? Anyone still writing?
No, sir.
No. No. First of all, let us see a very simple example. What has to be done? Hydrogen has to be replaced by halogen. है ना? क्या होता है? Simply hydrogen is replaced by halogen. ठीक है? Now, आपको दिया गया है इस तरह से CH3, CH2, CH3, and the same Cl2 in the presence of H nu. ठीक है? Now what we are doing? We are doing chlorination. क्या कर रहे हैं हम लोग यहाँ पे? Tell me guys what we are doing. अरे बोलो भाई, क्या कर रहे हैं यहाँ पे?
Chlorination.
Chlorination. What we are doing? Chlorination, है ना? And since you have seen H nu, so we are doing free radical chlorination. So this is something which is going to identify कि product क्या बनने वाला? What is the product going to? What we are doing here? We are doing chlorination in the presence of what? Light. That is why it is free radical chlorination. Next thing that you have to identify here is the number of hydrogen atoms. The number of different types of hydrogen atom. Okay, types of carbon. You will identify types of carbon. You will get types of hydrogen. Those who are not present yesterday, they are going to have problem here. Now, tell me guys, how many types of carbon do we have here? How many types of carbon? Madiha, Rabia, Deborah, Tarif. You guys were present na yesterday? Yes, Madiha, how many types of carbon or hydrogen? How many types of carbon?
So two.
Zors, I mean, can you please say it loudly?
Two.
Two, right? Because this is 1 degree, this is also 1 degree, and this is 2 degree. So here we have two same carbons. This carbon A, B, and C. So I can say that carbon A and carbon C are same, and carbon B is different. So here we have two different types of carbon atoms. That is why there will be two different types of hydrogen atoms also. And I can make two different products. What are the two different products I can make? I can make CH3, CH2, and hydrogen from 1 degree carbon will be replaced by halogen. What is the halogen here? Chlorine. Plus, I can make CH3 from the middle carbon, 2 degree CH and CH3. And one of the hydrogen will be replaced by halogen, that is chlorine. All of you got this? Yes or no? Please tell me.
Yes, sir.
What about others? Madiha, Tarif, at least those who are present in the last lecture, they would understand very easily what is happening here. One of the hydrogen is being replaced by halogen, and the halogen here is chlorine. No. Write a question. Determine the number of. Acha, all of these are what? If you remember the first class, these are monohaloalkenes, right? So we call this monohalo products. Each molecule here, it is having one halogen atom. That is why it is monohalo. Monohalo, dihalo, trihalo, we have all seen in the first lecture itself. Write the question, determine the number of products. Number of monohalo products formed on free radical halogenation of the following. Free radical halogenation of the following. Okay, so I'm not going to give you any reagents. We are just saying that free radical halogenation is happening. How many monohalo products will be formed? Okay, so write the questions. Write the question. I'm going to give you 5 minutes for this. Let me know once you are done. And send your answers in the Zoom chat, or you can send it on WhatsApp also. Okay. The problem is that you are not present yesterday. No? This concept is completely from the yesterday's class. Tell me, which question should I explain? Hafsa, which question should I explain?
So the first one.
First one. Okay. What is the degree of this carbon atom?
One.
Just give me a second, Hafsa. Okay.
Okay.
Sorry, okay. Then what is the next degree? This carbon atom. Other carbon atom is also Hafsa.
1 degree.
1 degree. Okay. Now, first of all, this first carbon atom, it is attached with 3 hydrogens. Correct?
Yes, sir.
Right. There will be 4 bonds. Now, with each carbon atom, there will be 4 bonds. So this carbon atom, it is attached with 3 hydrogens and it is attached with 1 degree. Correct?
Yes, sir.
2 bonds. Okay. What about the second one? It is attached with 3 hydrogens, right?
Yes, sir.
Right. And then with 1 degree. Correct?
Yes, sir.
I'm not saying that this carbon is 1 degree. This carbon is 1 degree. We know that. But it is also attached with 1 degree carbon. Correct?
Yes, sir.
These are the 4 bonds. So is there any difference between these 2 carbons or both of them are same?
It's same.
Same, right? So here we have only one type of carbon atom. And since hydrogens are attached to carbon, we are having rather 6 hydrogens. But all of those hydrogens are same. That is why how many hydrogens we are having? We are only having one type of hydrogen. So we'll get only one product. One monohalo product. Got it?
Yes, sir.
So you have to first of all identify the degrees. Then you will, for each carbon atom, write what are the groups attached. And if the groups attached are same, if the groups attached are same, then only you will say that they are same. Otherwise, they are different. So guys,
Okay,
take
sir.
1 more minute. 1 minute extra. That means you will get 6 minutes. And try to find. I know that Fia, you were not present yesterday. That is why I explained here. What can I do? You will watch the lecture, then only you will understand. Now, this is extra classes. And if you are missing the extra classes, I cannot take extra classes for extra classes, right? So just wait. You will watch the recording, then you will understand. And please don't, I mean, if you are not present in the extra classes, then what's the use? And you will not get time to watch the video recordings. Those get recorded, they get uploaded 1 day later. And we are having regular classes. At least you do something. You at least write the degrees of carbon. Na? Whatever number of carbons you are seeing, you can write the degrees, right, Fia? 1 degree, 2 degree, 3 degree. Fia, can you identify? Huh? At least do that, then you will see. Okay, Madiha is there. 1, 1, 2, 0. How 7? How it is 0, Madiha?
Sir, because carbon can only form like 4 bonds, right?
Sorry?
Sir, because like carbon can only form 4 bonds, right?
Correct. So
So like we already have CH3 attached with that.
So
Why will there be any more?
sorry,
Why will there be any more bonds then?
I am not where I am seeing there will be more bonds.
No, like how will we
Okay.
form any other more?
So what about here? What about here? Carbon is already having 4 bonds, correct, Madiha?
Yes, sir.
So why you are writing one product then?
Right. So then also it will be one product, right then?
Sorry?
So in the 7th one also it will be one
No,
product.
I'm not asking that. No, you tell me first of all here that here also. Just answer what you. I'm answering what doubt you had. Here also we are having 4 bonds, right?
Yes, sir.
What about here? How many bond does this carbon has? This carbon also has one bond with other carbon and 3 other hydrogens. So all of the carbon, they are having 4 bonds, right?
Yes, sir.
So why is anyone giving product? Tell me. So the number of bond is not the matter. The matter is how many hydrogen each one has. If there is even one hydrogen, for example, in the 6th one, there are 2 types of carbon. This is a carbon atom which is having 4 bonds, and this carbon does not have any hydrogen. That is why hydrogen is replaced by halogen. Now, if this cannot happen, so if there is hydrogen, it can be replaced by halogen. If there is hydrogen, it can be replaced by halogen, right, Madiha?
Yes.
Okay, so that is why. Do we have hydrogen here? Yes, we have plenty full of hydrogens. Now try to do 1 degree, 2 degree, and then see for each carbon atom if they are same or different. So time is over. So for the first one, I have seen one mono-halo product. For the second, we have only one type of carbon, or we have only one carbon. That is why we'll get only one product, right? So we'll write one mono-halo product, one MH product, okay, we will see here. Third one, we are going to have, see, this is 1 degree, this is 2 degree, this is 2 degree, and this is 1 degree. Now 1 degree, this is attached with 3 hydrogens, and it is further attached with 2 degree. Okay, this 1 degree, it is attached with 3 hydrogens and further attached with 2 degree. So both of these are same. And this 2 degree, it is attached with 1 degree carbon, it is attached with 2 degree carbon and 2 hydrogens. Here also same. So here we are having 2 mono-halo products, right? We'll get 2 MHP. If I look at the fourth one, fourth one, fourth one, all the halogen and all the carbon atoms are same. All of these are what? 2 degree. This is also 2 degree. Sorry. 2 degree. This is also 2 degree. This is also 2 degree. This is also 2 degree. All of them, they have 2 hydrogens and they are further attached with 2 degree carbons. So all of these are same, and there will be only one MHP because all of them are what? Same. One mono-halo product. Now let us look at the fifth one. So fifth one, we have this 1 degree. This is also 1 degree. This is also 1 degree. This carbon here is 3 degree. This carbon here is 2 degree. So 3 degree and 2 degree are different. We'll have to see what is about 1 degree. So this 1 degree carbon, it is attached with 3 hydrogens, and it is further attached with a 3 degree carbon. This 1 degree, it is attached with 3 hydrogens, and it is further attached with 3 degree carbon. What about this 1 degree? This is attached with 3 hydrogens, and it is attached with a 2 degree carbon. So this 1 degree is different. Okay, so what are same? These two are same. This one is different. This one is different, and this 1 degree is also different. So what I can say here, I will get 1, 2, 3, 4 products, 4 MHP. Now, then I talk about this. This is 4 degree carbon. So 4 degree carbon, it will not have any hydrogen. That is why we cannot replace hydrogen with halogen here. Even though we have 2 different types of carbon atoms. This is 4 degree. All of these are what? 1 degree. And all of the 1 degrees, they are attached with 4 degree carbon. That is why you can say we are only going to get 1 degree, 1 MHP. One mono-halo product, because all of the 4 carbon atoms are same. In the 7th question, if you see here, let us first of all write, this is 1 degree. This one is 3 degree. This is 2 degree. This is 2 degree. This is 2 degree. This is 2 degree. Now let us talk 1 degree and 3 degree. They are going to be obviously different. 1 degree and 3 degree are different. Let us talk about these 4 2 degree carbons. So if I talk about this one here, this carbon atom, this 2 degree attached with 3 degree, 2 degree. And all of them are having 2 hydrogens. So I am not going to talk about 2 hydrogens. Okay. So this 2 degree is attached with what? 3 degree and 2 degree. What about this 2 degree? It is attached with 2 degree and 2 degree. So I can say both of these are different. Both of these are different, right? Next, we are talking about this 2 degree carbon. This 2 degree carbon is also attached with 2 degree, 2 degree. So I will write 2 degree, 2 degree. That means both of these are, this carbon is same. Right? And let us talk about the last one. This 2 degree carbon, it is attached with 2 degree from here and 3 degree from there. So I can say that these two are same. This 2 degree and this 2 degree is same. And the other two, the bottom 2 are same. So in total, we have 1 degree. Then we have 2 different types of 2 degree. And we have 3 degree. So we are going to have total of 4 MHP. All of you got this? Yes or no? Please tell me. Rabah has also said.
Yes, sir.
Rabah, you understood the mistakes. Rabah, you understood the mistakes. Rabah, I am asking something, Rabah. Got this? Yes or no?
Yes, sir.
Got the mistakes? Yes or no?
What, sir? I can't hear you properly.
You cannot hear me properly. I'm saying,
Yes.
did you understand your mistakes?
Yes, sir.
Okay. All of you, please write this down. Fia, you understood it now?
Yes, sir.
Okay.
So we have to look at the different types of degrees and to which degree it's bonded also.
Yeah, correct.
Okay, sir.
First of all, you will identify the degrees and then you can easily identify that what they are bonded to. So 1 degree and 3 degree, they are obviously going, 1 degree and 2 degree, obviously going to be different. But when we have 2 degree, then you have to compare them, whether they are same or they are different. Okay.
Okay, sir.
Is everyone done? Yes or no? Please tell me. Now, you understood that how many products will be there. Now, let us also see how to write those products, how to form those products. So they will ask you, they can ask a direct question like this. Draw all monohalo products or monochloro products. Write all monochloro products formed by photochlorination of CH3 whole twice, CH, CH2, CH3. Okay. So see, photo means what? Light. And chlorination means what? Cl2. Okay. So photochlorination of this one. First of all, we will make this particular compound. Please see here, don't write now. Okay. So how many carbons? 1, 2, 3 carbon atoms. I will make 1, 2, 3 carbon atoms like this. 3 carbon atoms. And then we have CH3 on this carbon atom, CH3 and CH3. Okay. So we have now got this compound. So they are asking to write all the monohalo products that will be formed. Now, first of all, you will see what are the different types of carbon atom. So this is a different type of carbon atom. This is a different type of carbon atom. This is a different type of carbon atom. And this is a different type of carbon atom, right? This red one and this red one is same. We have just seen that. So we are going to form how many products? We are going to form only 4. From here 1, 2, 3, and 4. Now, what you are going to do? You are just going to attach a chlorine because they are doing photochlorination. You are just going to attach a chlorine on all of the different colors. So let us suppose if you are doing, we make for the red one. If I attach a chlorine on any one of the red one, then what I'm going to get? Chlorine like this. What you need to do? You need to just make the compound as it is. Okay. And add chlorine, red hai to red wale. One product is this. Then what else you can do? Let's do for the green one. So for green one, what I am going to do? Everything same. Everything same. And on the green one, you will attach a chlorine. Right? Then the next one. Let us take the blue one. Everything same. We'll attach a chlorine in the blue carbon. And for the last one, for the pink one, selecting your everything as it is, just as chlorine on the pink carbon. So these are the 4 products that we can form. All of you understood this? Yes or no? Please tell me.
Yes, sir.
So what actually is happening? From all of these different colors, one hydrogen is being replaced by chlorine. All of you done? Yes or no? Please tell me. Is everyone done? Oh, done, guys?
Yes.
Oh, no, Fia is not. Fia, write it quickly. Done, Fia? Okay. Now, see next. Let us suppose, first of all, write a note here. Please write. Free radical halogenation of alkenes is not a suitable method for preparation of haloalkenes. For preparation of haloalkenes, as we get mixture of mono and polyhalogenated products, which is difficult to separate. Which is difficult to separate. So, for example, listen to it very carefully. If you have not written now, no problem. Just leave the pen aside. Listen to this very carefully. Let us suppose in our industry there is a requirement of this compound. 1, 2, 3 prop, and here we have Cl, right? So this will be 1-chloropropane. We need this particular compound. How will we make this from photochlorination? We'll take alkane like this plus Cl2, and then we are going to react this in the presence of H nu, light. So what we are going to get, we want only this product, but what we are going to get, we are going to get a product like this and also a product like this. So obviously, if I am going, let us suppose that both of these are forming 50-50%, and I am starting with this propane with 100 molecules of propane. So I will get this as 50 and I will get this as 50. Even though it is not going to be 50-50, there will be some major product, some minor product. But let us assume that we are going to get at least 50-50. Then also, whatever alkane you are using, so you are using here alkane 100 rupees ka, and you are only getting the product for 50. So it is a loss, right? Can all of you see that? Yes or no? Please tell me. No. Can all of you see that? Why this method is not preferred? Because whatever input you are going to give the input, whatever reacting materials you are going to give, the reagents, the reactants you are going to give, that half of them at least is going to get wasted. Can all of you see that? Yes or no? Arey bolo bhai.
Yes, sir.
Yes, na? Okay. So that is why it is not a preferred method of preparation. It is not a suitable method of preparation. Also see, let us suppose if I am taking CH4. Please see, don't write anything, CH4. And I am treating this with Br in the presence of light. Br means bromine, Br2 in the presence of light. Now we have bromine will replace a hydrogen atom. I will get CH3Br. Now please remember, as soon as CH3Br is formed, if there is one molecule of CH3Br which is formed, please listen to this very carefully, leave your pen aside. If one molecule of CH3Br formed, then it does not mean that all the Br2 is consumed. There will be plenty of Br2 which will be left. Not all the reactant gets converted into product at once. You know, in 1 second reaction does not happen. That not all the CH4 will be converted to CH3Br in 1 second. So what is going to happen? First of all, whatever CH4 meets Br2, right? Because when we are mixing things, it is not necessary that all CH4 will meet Br2. And unless and until methane meets bromine, the reaction will not happen. So what happens here is when CH3Br is formed, there is plenty full of Br2 which is left. There is plenty full of CH4 which is left. And we have a new item here, CH3Br. Now tell me, is there hydrogen in CH3Br? Is there any hydrogen in CH3Br? Yes or no? Please tell me, guys. Bolu bhai, please answer. Is there any hydrogen in CH3Br? What happened? Rabah, Rabia, Tarif, Madiha.
Yes, sir.
Is there hydrogen? Yes or no?
Yes, sir.
कोई जवाब ही नहीं दे रहा. हम बंद कर देंगे एक्स्ट्रा क्लासेस. रिकॉर्डिंग देखिए, आप लोग को शांत रहना है तो ठीक है. And this is not a joke. I'm saying this with very seriousness. I'm not getting anything extra when I take these classes. Okay. So if you're not going to answer, watch the recordings. Tell me, is there any hydrogen in CH3Br?
Yes, sir.
Yes, sir.
And what? And this CH3Br can come into contact again with Br2. And as soon as it comes into contact with Br2, again a hydrogen will be replaced by Br and you will get CH2 Br2. See, the role of bromine is to replace hydrogen. उसको क्या मतलब उसके पास Br है या नहीं है? He doesn't even care if CH3Br is already having a Br. He is just looking for hydrogen. If there is a hydrogen, it will replace it. Again, the CH2Br2, it can come into contact with Br2 once again in the presence of H nu. And again, what Br will do? Br will say, hydrogen hai? Yeah, there is hydrogen. Yes, there is hydrogen. So we will get CHBr3. Again, this reaction can happen. And what we will get? CBr4. Now, after this, when Br comes, you will see, oh my God, there is no hydrogen. I cannot do anything. Okay. So here also you can see, I can get some product, obviously. All the CH3Br, please listen to this very carefully. All CH3Br, for example, if I start with 10 to the power 5, okay, I start with 10 to the power 5, then wait a second, 1, 2, 3, 4. It will be easy if I start with 4 into 10 to the power 5. So I'm starting with 4 lakh molecules. Let us suppose half of it gets converted. Half of it's 8 से start करते हैं. 8 से 8, 4, 2, 1, 16 से start करते हैं. These numbers are just to understand things, okay? These numbers are just for understanding things. Now, 16 into 10 to the power 5, that means 16 lakh molecules of methane. Let us suppose half of it, just for the possibility, the probability says I can, let's suppose only half of it get converted into CH3Br at once. So 8 into 10 to the power 5 will be converted to CH3Br. Now let us suppose not all CH3Br got into contact with Br2. Only half of them got into contact with what? Br2. So half of this will be converted into CH2Br2. Then let us suppose half of it got into contact with Br2 once again. They will be now 2 into 10 to the power 5, we will get CHBr3. Let us suppose half of it got converted or got into contact with Br2 and I will get 1 into 10 to the power 5. Now, what will be the total amount of products that we are going to get? See, we have a mixture now again. Yes or no? Please tell me. Can all of you see that? Yes or no?
Yes, sir.
That is why it is not a preferred method of preparation. Okay, so because we get what? We get mixture
Oh,
of
but if you take
mono
any
and poly.
method of preparation, you'll always end in one point, right? It's not that it goes on continuing. You'll end in one point. There will be some amount of wastage. So it's why this is not much suitable. This is
Because
happening in every reaction, right?
no, not every reaction. Only with free radical halogenation it is happening. It will not happen with all the reactions. Okay.
Okay.
So for example, see here our reactive part is hydrogen. When our reactive part was alcohol and we had only one OH, right? And when I reacted, for example, with HX, then one halogen will replace OH. It replaced the OH. Now this is not going to further react, correct? Because it does not have any OH now. Got
Okay,
it?
sir.
Anna?
Okay.
So that
Yes,
this
sir.
method is not preferred. Because the reactive site here is CH, hydrogen is reactive. Anna? And that is why what is going to happen? We are going to get multiple products, mono and polyhalogenated. So all of these CH2, Br2 polyhalogen, CS, Br3 polyhalogen, all of these are polyhalogens. Okay, so please see what is the problem here. The problem here is that we are having unreacted Br2. We are having unreacted Br2. That is why it is again reacting with what? The halogenated atoms again, once again. So if we take less Br, then the problem will be solved. So the next point you will write. And if there was less Br, then what would happen? Only this much would happen, because if Br2 is not left, then the further reaction cannot happen. So please write. To get monohalogenated, product, excess of alkane should be taken. Okay. So reaction you can write, for example, if you have C2H6 plus Cl2, so here this will be in excess, then you will get CS3CH2 and chlorine as major product. Okay, you can write like this. You can write another point. If halogen is taken, in excess, then CX4 will be major product. Is everyone done?